When we were factoring out the GCF, we talked about how this was like working backwards in a multiplication problem. So factoring out that GCF, we now have a multiplication problem that when we multiply out, we get that original polynomial. Another kind of factoring is when we're factoring a quadratic trinomial into two linear binomials. And this again is like working backwards. The factored form of x squared minus 7x plus 10 is x minus 2 times x minus 5, because when I multiply that out, x squared minus 5x minus 2x plus 10, I would get x squared minus 7x plus 10. So we're trying to find the multiplication problem that when we multiply it out, we get x squared minus 7x plus 10. We're finding two linear binomial factors that multiply to get this quadratic trinomial. Now we did some diamond work a little earlier in the class, and you can use a diamond to help you find these two factors. If the diamond is not helpful to you, or if you've learned another way, that's fine. You don't have to use it. But what we're trying to do here is find the two numbers that multiply to the C but add to the B. That will give us these two binomial factors. So I can use my diamond. I can, for this case, look for the two numbers that multiply to 10 but add to negative 7. What are the two numbers that multiply to 10 but add to negative 7? I know they both have to be negative so that we have a multiplication to a positive but an addition to a negative. So I'm going to think about my factors of 10, and I can see right away that 5 and 2 work here. Negative 5 times negative 2 gives me positive 10, but negative 5 plus negative 2 gives me negative 7. That means that my factored form is x minus 5 times x minus 2, which is equivalent to x minus 2 times x minus 5. When I'm asked to check, sometimes I'll use the box, sometimes I'll use the distributive property. I can use the distributive property here, x squared minus 2x minus 5x plus 10 is just x squared minus 7x plus 10, and yes, that gives me my original polynomial. So again, I can use my diamond to find the two numbers that multiply to the constant and add to the coefficient in front of the x. That allows me to write my factored form. If you can do this in your head without the diamond, that is fine. Here's an example. We're multiplying to 15, multiplying to the constant, adding to that coefficient in front of the x. So the two numbers that multiply to 15 and add to 8, this is an easy one since it's positive. 5 and 3 multiply to 15 and add to 8. X plus 5 times x plus 3. That is my factored form. I might be asked to check with the box because, again, this is the multiplication problem that gives me, when I multiply out my factored form, I get my original polynomial. So I can check that by multiplying out my factored form. X times x is x squared, 3 times x, 3x, 5x, and 15. And then I can look, I don't really have space, but I should write x squared plus 8x plus 15 and check. One case that I want to point out is when it looks like we don't have a quadratic trinomial. I want you to still try writing this as the equivalent trinomial with a 0x term in the middle. So it may look like this does not fit into our factoring quadratic trinomial case, but it does. We're just multiplying to that negative 9, but adding to 0. You'll start to see what types of cases this applies to, but it's going to apply when we have a subtracting of a perfect square, because that allows us to do 3 and negative 3. An opposite of a number allows us to add to 0 and then multiply to negative 9. So x plus 3 times x minus 3 is going to allow this case to happen, where we have x squared minus 9, but the minus 3x and the plus 3x canceled out. X squared minus 3x plus 3x minus 9. These two add to 0, giving me my original polynomial x squared minus 9. So this should really be called factoring quadratic trinomials. And this is kind of a honorary trinomial. It has an invisible 0x term. This is a similar one, x squared plus 0x minus 25. So what two numbers multiply to negative 25 but add to 0? Just 5 and negative 5. That's compared to this case where we're looking for two numbers that add to 0 but multiply to positive 25. This is a case that is not factorable, so you would write not factorable. And to show me why it's not factorable, you would show me that you tried 5 and 5 and negative 5 and negative 5, maybe even 25 and 1 and negative 25 and negative 1. These are all the factor pairs for 25, and none of them add to 0. 5 times 5 is positive 25, but they add to 10. Negative 5 times negative 5 is positive 25, but they add to negative 10. These obviously don't work. So this would be a case where it is not factorable, and that would be your answer. The other ones, we're just going to do our diamond. 12, negative 7, negative 8, 7, 25, and 10. And we're looking for the two numbers that multiply to the constant and add to the coefficient in front of x. From there, we write out our factored form, and then we check it with the distributive property, or if we're not forced to check it, we check it in our head. Yes, x squared minus 4x minus 3x gives me negative 7x plus 12. This is one that students sometimes have a hard time with, multiplying to negative 8 but adding to 7. So always try the factor pair of the number and the number itself and 1. This works. X squared minus x plus 8x gives me 7x minus 8. And then sometimes this is taught as a special case, but I don't really see any reason for that. And this is just the case where we're looking at what multiplies to 25 and adds to 10. It just happens to be that this is a perfect square. 5 times 5 is 25, and 5 plus 5 is 10. The only thing here is to get full credit, you can't just keep it as x plus 5 times x plus 5. You need to realize that that is a repeated factor of x plus 5. So your final answer is x plus 5 squared.